So hello students, welcome to our TEJAS series, our YouTube channel, Turito's YouTube channel. So today those were the two questions, both based on calculus, one definitely on indefinite integration and the other one, as you can see here, is on limits. So okay, let's start. See, the first question, which is a column match type, I won't be solving the entire question. See, if you would have solved it, that's really good. Otherwise, you just need a hint to solve this question. Okay. So first of all, we need to see that we have to solve these integrals I1 and I2 for values of a, which is -1 and +1. Okay. So here I will suggest in that case that why not to solve it just for those values which is required here. So a tan of x plus b, isn't that? So that means when a is equal to 1. So let's solve it for 1 and then the other one, rest of the cases you people can deal yourself. Okay. So now the idea is, see why I picked up this question, because of a simple manipulation that if we do, the question gets really simple to solve. Okay. Now what I will do here is, I will add and subtract 1 here. That's the only manipulation, okay, which I was talking about. So 1 plus sin x into sin of x plus b over cos x into cos of x plus b and integral of dx. Okay, so of course if I added 1, I need to subtract 1 within integral, so minus integral of 1 with respect to x. Now when you take LCM, what do we get? So therefore I1 is, so when you take LCM, see what are we going to get? Cos A, cos B plus sin A, sin B, and which identity it is? It's cos of A minus B. Okay, so shall I write it directly? So cos of A minus B, x plus B minus x gives us cos B. So that's it, which is a constant in numerator. Now that makes the thing quite simple, isn't that? And this is minus x plus C, of course, that we can write here, or we can add it at the end, won't make any difference. Now see, this is a very common question which you would have done it so many times earlier, and if you haven't, then let's look at it. It's again a trick here. I will multiply and divide by sin b and then writing sin b as x plus b minus x. Can I? Now what's the idea behind it? So the idea is that when I will expand it, then I will be able to get rid of one term from the denominator, bachon. So what am I going to get? So I am going to get cot b here, and then it is integral of sin a minus b. Identity, what is it? So sin a cos b. So shall I write sin of x plus b into cos x? That's what I said. And when you divide it with the denominator, one term in the denominator is gone. So similarly, minus cos of x plus b into sin x, and then we have cos x into cos of x plus b, bachon. Of course with an integral, and that's minus x plus c. So now it is nothing but cot b, and what gets cancelled here? Cos x plus b is this. So this is integral of tan of x plus b dx. So let us write it like this, minus integral of tan x dx and then minus x plus c. Now as a standard result, we know integral of tan of x is ln sec x, isn't that? So I1 for a is equal to 1 is cot b times ln of sec of x plus b minus ln of sec x and then minus x plus c. Okay, so if I divide it or use property of log, which says ln a minus ln b is ln a by b. So it is ln of sec of x plus b. So why not to write it in terms of cos? In that case, the position will get reversed. So it will be cos x over cos of x plus b, isn't that? Minus x plus c. Now let's see, do we have an option? We should. So it's cot b ln of cos, that's it. That's the option. Okay, so it's cot b times ln of cos x upon, so a matches with r. So we have two options here, and then you solve. And see, of course I'm not going to solve b for q because you have in both the cases. So solve for c or maybe d with a is equal to -1. So that's another thing. Now we all can solve it easily. Then you can match the answer. Whichever you get is the answer. Okay. So that was the first question from indefinite integral for today here, bachcho.